Welcome to the Math Record. Today I'll be covering the second part of the ICTM State 2017 Division AA Geometry, which I'll be answering questions 14 and 19. Okay, question 14. A line segment is drawn from point 4, 5 to point A on the y-axis, then the segment is drawn from A to B, which is on the x-axis, and then from B to 11, 3. Determine the total sum of the lengths of these three segments. So there's actually a really good trick to solve this question, and we're going to use the idea of reflection. So basically, let's graph our original point, which is 4, 5, and then our other point, which is 11, 3. So what I'm going to do instead is that I'm going to flip our 4, 5 across the y-axis to get -4, 5. And I'm going to flip 11, 3 across the x-axis to get 11, -3. So now I'm going to make a line that connects those 2 points. And this line should be the least total sum. And how do I know? Well, if you kind of connect this point, which is on the y-axis, to this point on the 4, 5, and then our x-axis, the point 11, 3, we can see what's happening. So the distance, which adds this, this, and this, is the same thing as adding this, this, and this. And how I know is that this distance is the same as this because we just reflected this point across to this side. That means this line is reflected across here. So that means those are the two same lines. And it's the same idea as this point reflecting across here. That means this line is reflected across here. So that tells us that this line is equal to this line is equal to this line. So that tells us that this distance, which is these three, added is the same thing as this plus this plus this. So what is the least total distance from -4, 5 to 11, 3? 11, -3. Well, that's just the distance formula. So our change in x is 15. -4 to 11 is 15. And 5 to -3, that's 8. So we could just use the Pythagorean theorem. So 15 squared plus 8 squared is square root is 17. And that is your answer for number 14. So you just gotta recognize it. So if you ever see distances that you need to optimize on a grid, just use the idea of reflection. Okay, question 19. The length of the radius of an inscribed circle of a right triangle is an integer r such that r is between 16.3 and 23.3. The length of each of the legs of a right triangle are also integers. If one of the legs have a length of 60, determine the sum of all possible distinct lengths for the other leg. Okay, so I'm just going to draw a general picture. So we have a right triangle, then we have an inscribed circle. So that's not really a good picture, but basically point of tangency. And then inscribed circles basically means that this is a radius, this is a radius. So points of tangency means these are 90 degrees. This is a right triangle, so this is 90. So since this is quadrilateral, this also has to be 90. So that means this length is r and this is r because it's just kind of a rectangle. So this is r and this is r. So one of the legs are length 60, so let's call this one 60. So that means this length over here is 60 minus r, plus this r is 60. And let's call this x. And based on geometry, which says common external points make the same length lines, basically. So that's not the exact definitions, but basically that's how I kind of explain it. So if this is length x, that means this is length x. And we could do the same thing for this point. So that means if this is 60 minus r, this is also 60 minus r. So now we can use the Pythagorean theorem. So 60 squared, which is 3,600, plus r plus x squared, that's just r squared, plus 2xr plus x squared is equal to x plus 60 minus r squared. So it's going to be x squared plus 120x minus 2xr plus 60 squared, which is 3,600, plus, minus 120r, then plus r squared. So this was just x plus 60 minus r squared expanded out. So now let's just take out things that are similar. So x squared, r squared, the 3,600. So we have 2xr is equal to 120x minus 2xr minus 120r. Okay, so let's just move x all the way to one side. So this will make 4xr minus 120x is equal to negative 120r. Okay, so we could distribute out our x, and that would be 4r minus 120. So negative 120r divided by 4x. Oh, sorry. Yeah, 4r minus 120. So we have our value for r minus 120. So all we had to do is that we need to plug in values for our r. Remember, r is between 16.3 and 23.3, and r is an integer. So that means r is equal to 17, 18, 19, 20, 21, 22, or 23. And whatever you plug in here should be an integer because x has to be an integer because it says the legs because r plus x has to be an integer. So all you have to do is just plug into your calculator to see which ones work. So 120 times 17, and then 4 times 17 minus 120. That doesn't work. Let's try 18. Okay, so that's going to be x is 45. So when it's 17, they get 45. I mean, when it's 18, it gets 45. Let's try 19. 19 doesn't work. Let's try 20. 20 gets 60. Okay, so 20 gets 60. Let's try 21. 21 gets 70. And then 22 and 23. So 22 doesn't work, which is a decimal, and 23 is also a decimal. Okay, so the only possible length for r plus x, which is the length of this side, so that would be is 18 plus 45, which is equal to 63, and this one's 20 plus 60, which is 80, and this one's 21 plus 70, which is equal to 91. So adding them all up together, that's 63 plus 80 plus 91, and you get an answer of 234. And that's your answer for number 19. Well, thanks for watching, and I'll see you at the next math record.